All right, so today we're talking about minimum spanning trees and Kruskals algorithm. We've talked about spanning trees. We talked about that last Thursday when we talked about how to determine how many spanning trees there were. Now, if a graph has 30 spanning trees, one of those spanning trees is going to be the minimum spanning tree. That would be the, oops, that's not what I wanted to do. That would be the tree with the lowest weight. Come on, technology. There we go. So a minimum spanning tree would be the spanning tree with the lowest total weight. And to find the minimum spanning tree, we are going to run an algorithm called Kruskals algorithm. Okay? And this is very similar to cheapest link. Okay? The difference is going to be what we're looking for at the end. Okay? We are not going to be looking for a Hamilton circuit. That's not what we're after. We're after the minimum spanning tree, which is going to change the rules a little bit for the algorithm. So what we do is we start by picking the cheapest edge in the graph and then the second cheapest edge in the graph, just like we did for cheapest link algorithm. So the two cheapest edges, no matter what they are, even if it's a tie, we pick the first two cheapest edges in the entire graph. And then we're going to continue to pick the cheapest edge. However, now we don't have to worry anymore about having more than two edges from a single point because that is not a problem for trees. The only thing we have to worry about is we cannot allow any circuits to form anywhere in the entire graph. Okay? As we're picking our edges from cheapest to most expensive, every time we pick an edge, we need to make sure that it does not close a circuit. Okay? That's our big rule. We cannot have any circuits forming in our spanning tree. Okay? And we're going to continue to pick edges until we have a spanning tree, which means the graph is fully connected, no circuits at all. Okay? Once we've gotten to that point, we will have the minimum spanning tree. We are going to make sure that every vertex is connected, but we will not use every edge. Okay, we want to make sure that all of the vertices are connected to each other by a tree, which would be the spanning tree. And if we do that correctly, our answer should be the minimum spanning tree every single time. So I've always found that the best way to teach this is to jump in and do a couple of examples. So I have two examples to go through today, and then we will call it a day. So Kruskals algorithm, again, it is extremely similar to cheapest link algorithm in that we will pick the two cheapest edges in the graph. And then as we continue to pick the cheapest edge in the graph, our only rule is we cannot allow any circuits to form. We can have as many edges as we want from a specific vertex, like we could have 6 from one vertex if we need them. That's not a problem for trees. What we cannot have are any circuits, okay? And we're going to keep picking edges until the graph, until it's connected and we have no circuits, okay? So here we go. We'll start with this graph here, which is our, if you don't recognize it, that is the graph that we looked at the beginning of this unit for the Amazonian rainforest telephone network. Here is how, this is Kruskals algorithm is what I ran to come up with the answer, okay? So we start by choosing the cheapest edge in the entire graph. And the cheapest edge in the entire graph would be, anyone? Oh, there it is right there, GF 42, okay? Okay, so we pick that edge, that's the cheapest edge. Then we pick the second cheapest edge. Again, just take a second, look at the numbers that have not been picked yet. Again, we've already picked that one, so it doesn't need to be considered anymore. The next cheapest edge would be 45 from B to D. So we would select BD. Okay? Now those are not connected. If they're not connected, then there cannot possibly be a circuit forming. So there's no eliminations, and we just pick the next cheapest. Okay? Well, the only other one that's below 50 is this 49 right here. So we would pick AD next. For 49. Now, if we look at what we've got, that will eliminate this 51 because that would close a circuit. Okay, and we can't have that. We can't have any circuits formed. So we can no longer worry about that 51. It cannot be picked. So we go on and we pick the next cheapest edge in the entire graph. Which would be DG, which is 51. So we pick this 51 because that is the next cheapest edge. That will once again cause an elimination because now if we were to pick edge AG, that would form a circuit. So we no longer have to worry that, not that we were anytime soon going to be picking the 74, but the 74 is eliminated. It is not a choice anymore. So then we pick the next cheapest. See how this works? Kind of just going through this over and over again. That would be 53 from D to, or C to D. Now that's going to cause a couple of eliminations because it creates a couple of places where we could have circuits. CG would close the circuit and CF would close the circuit. So those are both eliminated, and so would BC. So we only need to choose one more edge. So we need to pick the next cheapest. Would be CE for 59. Okay. Now notice that in theory, that would mean that we don't use the 62 because that would close the circuit. So look at what is highlighted there. That is a spanning tree. It spans the entire graph. It connects all the vertices to each other. Now, unlike circuits, we can't state that by listing the vertices because they're not connected in any particular order. If this were on paper, I would actually make you draw that, but we can't do that on Google Forms. So instead, I've only asked you to give me the weight. So to get the weight, we add up all of the numbers that we've selected. So we add those up, 42 plus 45 plus 49 plus 51 plus 53 plus 59. And we get our minimum spanning tree, which is the highlighted tree, has a weight of 299. Okay? So we go through, we pick the cheapest edges, and as we go, we eliminate any edge that would cause a circuit to form. Once we have a spanning tree, which are the 6 circled edges there, the 6 highlighted edges, we simply add up their weight, and that's our spanning tree. Now, on the homework, I'm going to ask you in the Google form to explain your selection process. So what I've written on the right in red and blue, that is more or less what I'm looking for in that box. Okay? Now, maybe doesn't need to be that detailed. You could just say select GF, select BD, select AD, eliminate AB, select DG. See what I'm saying? Just go through your thought process so that I know what you're doing. Okay. That way, if you're way off base, I can make contact with you and help you get it fixed so that when you do it again, you can get it right the second time instead of having to do it 850,000 times between now and May 22nd in order to earn your credit. Okay? So grab a screenshot if you want one. That is the complete solution to our first example. We're going to do one more. I do have a Google form put together for you. It has 4 problems on it. And we will get that posted to Google Classroom once we finish the lesson here. Guys, anybody have any questions before we advance? Grab your screenshot if you want it. We got one more question to do. No one is jumping at the opportunity, so here we go. So here's our second example. This is a K6. Okay, again, we're going to run Kruskals' algorithm on this graph. Okay. So again, we go in here and we find the cheapest edge in the entire graph. Okay, take your time, make sure you get it right. It would be MP for 394. Then we pick the second cheapest. So there's the cheapest, meaning we are definitely going to use PM. Isn't TK? Oh, it is. Crap. Okay, you're right. MP would be the second cheapest. That's what I get for not practicing. Okay, let's fix that. You are correct. MP is not the cheapest. TK is the cheapest at 248. Fortunately, since we're picking the 2 cheapest edges in the graph, making a mistake that early is not a problem as long as you get one of the 2 cheapest. Okay? Stupid me. All right, moving on. So there's our 2 cheapest edges in the graph. We've picked those out, TK and MP. Okay? Good catch on that one. I completely missed that one as I looked at my graph. And that's why you need to take your time. Don't rush. Okay? Now, at this point, those 2 pieces are not connected, so there are no eliminations. We simply go to the next cheapest. I'm going to take my time this time and make sure I'm 100% correct in stating that KM is the next cheapest at 447. Now, those are now connected, so that allows us to eliminate some edges here. Okay, we cannot use PK because that would close a circuit. The 592 is out. We cannot use TM because that would close the circuit. The 695 is out. And we cannot use TP. Although hoarders would be very sad to hear that TP is not available because that would close a circuit. Okay? I think that's all of our eliminations at this point. So now we would pick the next cheapest edge. So we look at the numbers that are not crossed out, and the next cheapest edge is AC at 533. Okay, AC is not connected to our other piece yet, so picking it will not cause any eliminations. Okay, so here there's no eliminations. And we would pick our next edge. So looking at our remaining options, it looks to me like 656 for CK is our next best option. Now notice that is our spanning tree. So in theory, everything else would be eliminated at this point. because every remaining edge closes a circuit. So now all we need to do is add up our weight. So we had 248 plus 394 plus 447 plus 533 plus 656. And we add those up to get our total weight. So 248 plus 394 plus 447 plus 533 plus 656 is 2278. Okay, so on the Google form, again, each question will have 2 boxes to fill in. The first box, all I want is the weight. So just that number that I just circled down there, 2,278. And then the other box is going to be a paragraph response. Again, in that box, I want you to explain your selection process. So you just need to go through and say, select TK, select MP, select KM, eliminate PK, TM, TP, select AC, select CK, and then show me the addition down at the bottom. And that would be good enough. That would cover your work. Okay? Okay, any questions? I'm pretty sure that's it for the notes. It is, okay. Grab your screenshots if you want them. Otherwise, I will be posting your Google Form assignments, your second to last assignment of the year, to Google Classroom. If you do not have any questions for me, you can go work on that. That assignment is due tomorrow at 3:30. Not a big deal if you made it here late, okay? So please, please, please make sure you're getting your work done.